Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have discussed about one numerical problem based on the Newton's law of gravitation. Today we will be doing or solving another numerical problem which is also based on the Newton's law of gravitation. And as we have said, we are taking these numericals from concepts series book, and I will be writing the questions so that the students who do not have the book with them can easily understand the problem or grasp the concept in a better way. Okay. So without wasting time, let us move on to our class. Please take out your pens and copies, as because when you are solving numerical problems, it is very important to do it on your own or do it side by side along with me. Okay. So I think the impression in your brain will be better. It is also good to write when you are studying also, but definitely when you are doing any numerical problem, it is of utmost importance that you do it in your copy. Okay. So let us take another question. What is the question saying? First of all, let us write down the question. The question says that a pebble or stone, you can also consider it a stone. Say a stone is dropped freely, okay, in a well from its top. Okay, so it's dropped freely in a well from its top. Okay, fine. Then what is saying? It takes 20 seconds for the pebble. It takes 20 seconds for the stone to reach the water surface in the well, to reach water surface in the well. Fine. Okay, then what is saying? taking the value of g. Okay, considering the speed of the sound to be 330 meter per second, and okay, so what it is saying, I am just giving a part of it. Find subpart 1 says depth of the water surface, depth of water surface in the well, depth of water surface. Fine. What is the second part saying? Second part is time when the echo is heard after the stone is dropped. Time when echo is heard after stone is dropped. So these are the two questions that you need to determine. Fine. Okay. So I think everybody just pause the video for a second or for a minute. Read the question, copy it in your notebook, and then we will be starting the solution. Okay. So let's begin the solution. So first of all, as I have said, we should note what are the given informations. Okay. So a stone is dropped into the well freely. That is falls under the effect of gravity. Now what happens? It takes 20 seconds to reach the surface of the water. From this information, you have to calculate what is the depth of the water surface. Fine. So first of all, note down the given conditions. Okay. So what are the given things here? Given is a stone is dropped, isn't it? So when it is said is dropped, what happens? Actually, the initial velocity of the stone is 0. So you can write initial velocity, which is written by the letter, represented by the letter u, is equal to 0 meter per second. So this is the first piece of information that we have. Second is that it takes 20 seconds for the stone to reach the water surface. So we can write time taken denoted by the letter t is equals to 20 seconds. Okay, and two things have been mentioned in the question. I forgot to write it down. That take the value of g as 10 meter per second square and It has been given that the speed of sound is 330 meter per second. Okay, so speed of sound, I am writing that Vs or sound. Speed of sound is 330 meter per second. So these are the two pieces of information that has been provided additionally. Okay, fine. So you can also add it in the given box. So acceleration is equals to g is equals to 10 meter per second square, and what is the other information? Velocity of sound is 330 meter per second. Fine. Now what you need to calculate, you need to find the depth of the water surface. So while calculating the depth of the water surface, so we can, so what are the information? Initial velocity is 0, time taken is 20 seconds. We have to find out the depth, or rather you can say we have to actually find out the S. Okay, in our equations of motion, so denote it as S. So which equation can be used? If we use the equation V equals to ut, there is no S, so we cannot use it. If we use the equation S equals to ut plus half gt square, yes, it's a valid equation because time is mentioned as well as the initial velocity is given, acceleration is mentioned, so we can easily find out the depth. So let us do the calculation part. Okay, so I am just erasing the left side so that I can solve the problem on the left side using the data and copying the data from the right side of the board. Okay, so solution, the first part of the problem says that we need to find out the depth of the well. So for that, what we have to do, we have to use the equation S equals to ut plus half at square. So let depth of water surface be S. Okay, so we can use the equation, therefore we know that S is equals to ut plus half a t square. Now see, here the value of acceleration due to gravity should be taken as positive. Why? Because when the stone is dropped, that acceleration is in the direction of the motion. It is causing an increase in the velocity of the stone. The earth is attracting the stone and it is falling down. So the direction of force and direction of motion are same. So acceleration should be taken as positive. Okay. Now, or we can write it as S is equals to 0, time is 20 plus half into 10 into t square is 20 square. So this term turns out to be 0. Okay, so S is equals to 0 plus, this is 5, so 5 into 400. Okay, and how much is the value? 5 into 400, it's 5 for the 20, and there are additionally 2 zeros, so 2000 meter. So the depth of the water surface is actually 2000 meter, or you can also consider it to be 2 kilometer. Okay, whatever it is. So this is the first part of the solution. I hope the first part is clear to all of you. Okay, now the second part says that what is the time after which the echo is heard. Now what is echo? First of all, try to understand what is echo. See, often you have gone to visit the mountainous or hilly regions, and or live with mountainous regions when sometimes there is a large empty ground. Okay, and there are some walls or obstacles at the end of the ground. When you shout out loud, you feel that when you shout out loud, it feels like that the sound that you are producing is once again being repeated. Okay, and this phenomenon is called echo. Actually, what happens when you shout very loudly, the sound produced by you goes on through the air and strikes a wall, and it reflects back. Okay, after a certain interval of time, and when it reflects back, we hear that the sound is being repeated again. So this is called echo. Now, to understand this, the time after which the echo can be heard, you have to think that first of all, when the stone is dropped, that 20 seconds time will be obviously taken. It will take that 20 seconds time because when it is being dropped into the well, so it will first of all take the 20 second time to reach the water well surface. Okay, so just if we just diagrammatically understand this, say this is our well. Okay, it is quite depth, more deep. Okay, more deep, not a problem. So here is the surface of the water. Okay, now when you drop the stone, what happens? The stone actually first just understand the process. The stone from here falls. Okay, so it will take some time. How much time it takes? It takes some time of 20 seconds. Okay, 20 seconds. Now after it falls, it splashes into the water and produces sound. Actually that sound will again travel back, and if a person is standing near the mouth of the well, that person can hear the sound of the splash. Okay, so here is a person standing and that person can hear the sound of the splash. Okay, so we need to calculate, we have already this time 20 seconds, we need to calculate how much time does the sound take to travel this distance. So we have calculated the depth of the stone, and the depth of the stone is 2000 meter. Okay, so if we take that, so actually the sound is traveling at distance of 2000 meter, isn't it? Fine. So we know that speed of sound is actually nothing but distance traveled by the sound by the time taken. So the time taken by the sound to reach the surface of the well, or to reach the mouth of the well, T dash will be equals to distance of the or depth of the well by the velocity of the sound. Now depth of the well is how much? It is, as we have already seen, it's 2000 meter. So divided by the sound is 330 meter per second. So cancels out and this turns out to be something 33 into 66, I think. Okay, so 33, how much it will come out? It will be recurring decimal. Okay, so this will be something like 6.67 seconds. Okay, fine. So initially the stone took 20 seconds to reach the water surface. After that sound is produced, and then the sound comes up and the sound is heard. Okay, so the total time taken by the if we consider the total time taken for hearing the sound, for sound to come to the mouth of well. Actually this is not echo. Basically what happens here, we are hearing the original sound, but in the question that we mentioned as echo, it is not actually echo. It is actually what we are hearing, the original sound, the time taken to hear the original sound. Actually after the sound is being produced, it comes to the surface of the mouth of the well, and that time you are calculating. So that time is actually basically summation of T and T dash. So it turns out to be 20 plus 6.67, and that turns out to be 26.67 seconds. Okay, approximately you can consider it to be 26 seconds. Okay, so this is the calculation. Okay, so I think the calculation part is clear, and the concept is also, I think, okay with you. Okay, so here with this lecture we come to the end of the chapter Newton's laws of motion. In the next lecture we will be starting with the new chapter. We will be talking of pressure, fluid pressures and atmospheric pressures, and etc. etc. So basically that's a separate chapter. We will be starting on the next lecture. Okay, so till then please do study well, and if you have any query, please do mention in the comment section. We will be happy to solve your problem. Till then please do study well. Thank you. Goodbye.